Hello and welcome to lesson number 8. This is the third lesson in Unit 2B of our grade 10 academic math class. This is the sine law. So what we're doing in this lesson is building on the creation of tools that we can use to find missing sides and angles in non-right angle triangles. In shifting away from right angle triangles, we lost the ability to use the Pythagorean theorem and primary trig ratio, since without a hypotenuse, neither of those tools functions any longer. We added the cosine law, which is a variation on the Pythagorean theorem. And in this lesson, we're going to look at the sine law, which will replace and become our third and final tool to use with non-right angle triangles. So the sine law is just written right here. There it is. You want to take a second to write that down. Shouldn't take you too long. The idea behind the sine law is that there's a proportionality between all of these sides and angles, and specifically the sine of a given angle in any triangle. Right angle triangles included, but any triangle at all. This again sort of builds on the idea that we have a dummy check where the proportionality of sides and angles has to sort of make sense. Largest side would be across from the largest side would be across from the largest angle, etc. Smallest side, smallest angle. So when we're talking about the sine law, we write it this way, where sine A over little a equals sine B over little b equals sine C over little c. You don't really use all three of these at any given time. You might just use, for example, these. It's a sort of a 4-variable equation where you need to have a side angle pair, which is what we go on to say over here. And a side angle pair, of course, is having the side and the angle across from it both being known to you. And then with one additional piece of information, then you can work to find the fourth. And that's what it says in the little paragraph there. So the first thing we're going to do in this lesson is prove that the sine law works. And if you want to take a moment just to copy this down, you'll see that it proves the sine law. I'll take a second here, just hit pause, copy it down. When you come back, we'll talk through it. Okay, you're back. Now what we've written out here is sine A over little a, and sine B over little b, and sine C over little c. We've written it all out as displayed here. And what you'll see when you actually do the division of sine 28.96 degrees divided by 4, and sine of 104 degrees 0.48 divided by 8, and sine of 46.57 degrees divided by 6, it all comes out to 0.12. So therefore, all three sine ratios are equivalent for this triangle. It's a proof, and this is true of any triangle. We're going to do it one more time just to prove it. So let's get ourselves some writing here. We are going to take this triangle, and again, we're talking about side angle pairs. So if we're talking about an angle right here, oh, that's not what I wanted to do. If we're talking about this angle here, I want to write on that. I don't know why it's fighting me on this. It's embarrassing. All right, maybe I won't write on it. Maybe I'll just write underneath it. But we want to be talking about the sine of 60 degrees divided by the side across from it. That's a root 3. And then the sine of 30 degrees, and that will be divided by the side across from it. That's 1. And then we have the sine of 90 degrees, and the value across from it is 2. And we're going to type these things into our calculator. So let's have a look. We have the sine of 60 divided by square root 3 equals 0.5. And you can be doing this on your calculator as well if you'd like. The sine of 30 degrees divided by 1 equals 0.5. And lastly, the sine of 90 degrees divided by 2 gives you 0.5. So we've proven it again. Therefore, again, we can write this down. I'm not going to bother. I want to save us some time. But the idea is that well, I guess I'll write it down. All ratios are equal. And this, of course, proves the validity of the sine law as a tool that we can use. So let's go have a look. We're going to do example B here, using the sine law given 2 angles and 1 opposite side. So given a triangle ELF, where angle L is 58 degrees. So again, I've written out the table and I've sort of sketched the triangle here. Let's get some of these values in. So we have L being 58 degrees, and angle F being 22 degrees, and side little e being 63.8 degree, or 63.8 meters. So what you'll notice right off the bat, and I'll write these things into the triangle too, I guess. 58 degrees, 22 degrees, and side e 63.8. So what you'll notice is we don't actually have any side angle pairs right out of the gate. Now visually in the table, that would be an angle and the side across from it. You'll notice that we don't have any complete pairs at the moment. Visually in the triangle, you would need to have the side and the angle across from it, angle, side across from it, angle, side across from it. So we don't have any complete pairs. However, because we've been given two angles and we know that the sum of interior angles equals 180 degrees, we can take a bit of a detour and we can find angle E first. So we can find angle E. We can find that by taking 180 degrees and subtracting the other two that we have. So 58, 22. Let's put it through the calculator and see what we get here. So we have 180 minus 58 minus 22. That's going to give us 100 degrees. We'll pop that in. And you'll notice now what we've been given, or what we have found with, without using any complicated trigonometry, we have a side angle pair. And that's the side angle pair we're going to use. The piece that we want is side little f. So we're also going to be using 22 degrees. So let's write out our sine law. We're going to find f. So find f. There we go. So we're going to write out the sine of angle. Let's use the letters first, just this one time. The sine of angle E over little e equals the sine of angle f over little f. And now we're just going to substitute in. So the sine of angle E we figured out to be 100 degrees is going to be over 63.8. And we have the sine of 22 degrees over our unknown, our f value. Now what you see about the sine law here, which is really nice, is that again we've set up a proportion to values that are equal to each other across an equal sign, and we can work this by cross multiplying. So we have f times the sine of 100 degrees equals 63.8 times the sine of 22 degrees. In order to isolate f, we are going to divide both sides by 100 degrees. Divide both sides by the sine of 100 degrees. Then we get f equal to, and we're going to round this to 1 decimal place. So again, what I'd like you to notice is that I'm not doing any math here until I get to the very last step. I don't want to be rounding things like sine 22 degrees or sine 100 degrees and then popping numbers in that are already rounded. I'm going to round in the last step and the last step only if I can. So 63.8 times the sine of 22 degrees equals, and divided by the sine of 100 degrees equals, and we have 24.2, and our unit of measure is meters. Therefore, and there we go. So in this particular case, we weren't given a side angle pair right out of the gate, but what we were able to do was determine what that third angle was using the sum of interior angles, a tool we carried over from the first half of this unit with right angle trig, and then we were able to set up the sine law because we had a side angle pair at that point. So we're going to stop this video here. We have a couple more examples, one where we find an angle, and then one where we solve an entire non-right angle triangle using the sine law, and then we'll be off to the races. So we'll see you in part 2 of this video.